All right, we are going to be talking more about trigonometry and the unit circle. So again, to memorize the unit circle, that will be one of your tests this semester, is just to draw and label the unit circle without looking. So again, just to go through, first of all, label your axes: 1, 0, 0, 1, -1, 0, 0, -1. Then label the ordered pairs. All of the denominators are 2's. Go for the outside pattern, Q1, quadrant 1 and quadrant 2, these two, 1 and 2. It's going to go ascending, so it's going to go, when we're doing the outside, it's going to go 1, 2, 3, 1, 2, 3. Okay, for quadrants 3 and 4, you're going to descend, 3, 2, 1 on the outside, 3, 2, 1 on the outside. Okay, and then for the inside numbers, you're going to go 3, 2, 1, 3, 2, 1, 3, 2, 1, and on the inside on the bottom, you're going to go 1, 2, 3, 1, 2, 3. Okay, and so there's our ordered pairs. Now we're going to do radicals. All the 2's and the 3's on top get radicals. So see all the 2's and the 3's? I put radicals over now. All right, so then we'll do our signs. In the first quadrant, everything is positive. In the second quadrant, the x's are negative, the y's are positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, x's are positive and y's are negative. And then we got to do our degrees. You add 30, 15, 15, 30, all the way around. So starting at 0, add 30, add 30, add 15. Add 30, add 15, add 15, add 30. And you just keep doing that. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30. Add 30, add 15, add 15, add 30. Your radians, okay, you're going to go in order ascending 3, 4, 6. So it's, the bottom is 3, 4, 6. And then over on the other side, so your denominator is 3, 4, 6, 3, 4, 6, and that should say descending. Quadrant 3 and quadrant 4 are going to be 6, 4, 3. See, the top is 6, the middle is 4, the bottom is 3. Your numerators for quadrant 1, all are pi's. For quadrant 2, subtract 1 and add a pi to the denominator. So my denominator here is 3, 1 less than that is 2, add a pi is 2 pi. Denominator is 4, subtract 1 is 3, add a pi. Denominator is 6, subtract 1 is 5, add a pi. For quadrant 3, add 1 pi to the denominator. So my denominator is 6, add 1 is 7 plus pi. Denominator is 4, add 1 is 5 plus pi. Denominator is 3, add 1 plus pi. And for quadrant 4, just remember 5 days a week I go to 7-Eleven. 5 days a week I go to 7-Eleven. All right, and then we need our radians for counterclockwise. You're going to go 0, pi over 2, 2 pi over 2, which reduces down to pi, 3 pi over 2, and 4 pi over 2, which reduces down to 2 pi. So we have, 0, pi over 2 at the top, 2 pi over 2 on the side, which reduces to pi, 3 pi over 2 at the bottom, and 4 pi over 2, which reduces to 2 pi on that end. And there, my friends, is your unit circle. All right, keep memorizing. All right, so counting in radians on the unit circle. What you do is you divide the numerator by 2 pi, because 1 whole time around would be 2 whole pi's. Okay? The quotient is how many whole times you go around the circle. The remainder in pi is the new numerator. Travel to that angle, and you've got your reference angle in the triangle. So 11 pi over 3. If you notice, if you look, 11 pi over 3 isn't in the unit circle because it's bigger. So if I figure out how many times 3 goes into 11, that would be 3 whole times. Take away 9 would leave 2 left over. So I'm going to go 3 whole pi's plus 2 more pi over 3. Okay, so this would be 1 pi, this would be 2 pi, this would be 3 pi, and then I have to go another 2 pi over 3. Well, I don't know how to count 2 pi's over 3 from here. I can go from here. 2 pi over 3 would be right there, 120 degrees. Okay, but I'm not starting from here, I'm starting from here. So what you do is you count the steps from 0 and then count that many steps from pi instead. So from 0 to 2 pi over 3 would be 1, 2, 3, 4, 5 steps. So if I start from here, 1, 2, 3, 4, 5 steps, that would put me right here at 5 pi over 3. And this would be theta. Okay? So 11 pi over 3 is the same as 5 pi over 3. Okay? Alright, and then to do negative 25 pi over 4, and I made a mess out of my unit circle. Darn it. I'll change colors. So 4 goes into 25. 6 times. Take away 24 leaves 1. So I have to go 6 whole pi's plus 1 more pi over 4. But it's negative. So what I do on negatives is I go to the positive and then reflect over. Okay? Or you could go backwards. If I went backwards, this would be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi backwards, right? And then I have to go another pi over 4, which is 1, 2 steps. So if I go backwards and I go 2 steps this way, that puts me right here at 7 pi over 4, negative 7 pi over 4. If you did the positive, like I said, if you don't like counting backwards, which I don't particularly care for, you could actually go forwards and then just reflect. If I went forwards, this would be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and then another pi over 4 would put me right here. That would be positive 6 pi plus 1 pi over 4. So to go negative, all you do is just reflect down, and that puts you at the 7 pi over 4. Okay, so you can either count backwards or you can count forwards and then reflect down, reflect over x. Alright, so drawing angles in a standard position and coterminal angles. Alright, so your initial side, remember, in the unit circle or on a coordinate system is always the x-axis. So if you have a positive angle, you go counterclockwise and stop at the angle you're going at. That would be a positive theta. If you were going backwards, if it was a negative, then you start here and you count how far you go, and that would be your negative angle. Now, coterminal angles are coterminal whenever they differ by an integer multiple of 360 degrees or by an integer multiple of 2 pi degrees. And the reason that is because there are 360 degrees in a circle, or in radians, there are 2 pi radians. So we call them coterminal if they basically differ by a circle. So let's say that I was trying to find a coterminal angle of 30 degrees. Well, if I want a positive coterminal angle, I'd add 360, which would give me 390 degrees. And if I wanted a negative coterminal angle, I would subtract 360, which would give me negative 330 degrees. These two angles would be in the same position as 30 degrees. It would just have an extra wrap around the circle. For example, this would be 30 degrees, about, okay? If I went 390 degrees, I would go all the way around once, that would be 360, plus another 30 would be 390 degrees. And you can see that it's in the exact same position as 30 degrees. That's why they call it coterminal, because they share the same terminal side. It's just that 390 gets a little dizzier. You get a little dizzier going to 390 than you do going to 30. 30, you just go here and stop. 360, you got to go all the way around once, and then an extra 30. That's why you get more dizzy. Okay, if you were going to do in radians, let's say that I had 2 pi over 3 radians, To get a coterminal angle in radians, you would add 2 pi, or you would subtract 2 pi. Now these, you're going to have to get a common denominator, so it would be 3. So if I multiply the top and the bottom by 3, this would be 6 pi over 3, because times 3 times 3. So that would be 8 pi over 3 would be my positive coterminal angle. Again, this would turn into 6 pi over 3 with a common denominator, which would give me negative 4 pi over 3. And those are my coterminal angles in radians. Alright, so it says find and draw a positive angle and a negative angle that are coterminal with the given angle. The given angle is 30 degrees, so that would be right here. There's 30 degrees. To get a positive coterminal angle, I add 360, which gives me 390. So to draw it, I would go all the way around one time, plus another 30, and that would give me my 390 degree angle. There's my positive coterminal. To get my negative coterminal, I take my original and I subtract 360, which gives me negative 330 degrees. So if I graph that, starting here, I would come around and I would go, this would be negative 330 degrees. Okay, there's your coterminal angles. Notice the angle looks exactly the same. It's just the distance you travel to get there is what's different. But they have the same terminal side. Alright, so negative 150. If I'm going to draw 150, this would be positive 150. From here to here would be positive 150. I don't count very well backwards, so if you go positive and then reflect down, that would be right here at 4 pi over 3, or at 240 degrees. Okay, so this would be my negative 150 degrees. So I start here, and I'm going to go down to here, and that would be negative 150 degrees. There's my original. Okay, so to get my coterminals, to get a positive coterminal, I'm going to add 360, which gives me 210. And if I graphed 210, oops, I reflected wrong, my bad. If this is positive 150, then this is negative 150. Right? I'm sorry, I reflected down the wrong way. I reflected from 2 pi over 3 would be down here. So, my bad. There's your negative 150 degrees. Oops, and I meant to do that in green. Okay, so now to do my positive coterminal angle, it's 210 degrees, which you could see would be just like this. So it's the same angle, my arrow is going to be different. When I draw it in purple, there's my 210 degrees. And then to get my negative coterminal angle, I take negative 150 and I'd subtract 360. And that gives me negative 510. So to graph, or to draw negative 510, well, this would be negative 360, right? And then to go a negative 150 would be all the way back around to here. And that would be my negative coterminal angle. Okay? Alright, 2 pi over 3 radians. And 2 pi over 3 is right up here. So my initial 2 pi over 3 is up here. To get a positive coterminal angle, I'm going to take my 2 pi over 3 and I'm going to add 2 pi to it. To get a common denominator would be 3, so times 3 times 3 gives me 6 pi over 3, which gives me 8 pi over 3. And if I draw that, okay, I would go 2 whole pies, 1 pi, 2 pi, plus an extra 2 pi over 3, which would be up here. Again, same angle, just had to go around the circle one time. To get my negative coterminal angle with 2 pi over 3, I would subtract 2 pi, which we already said was 6 pi over 3, and that would give me negative 4 pi over 3. So if I graph that, I could go to positive 4 pi over 3 and reflect up, which would put me back up here. Alright, or if you draw it, this would be a negative negative pi, right? And then you would go one more pi over 3 up, which would be right to there. Okay? Alright, so you do this one, you don't have to draw it, they just want you to find the measure of 2 angles, one positive and one negative. Hit pause, come back when you're ready. And all you do is, to get a positive one, you add 360. To get a negative one, you subtract 360. So this would be positive 132, and this would be negative 588. Alright, in radians, you do this one, hit pause, come back when you're ready. And hopefully you got 2. If I take 8 pi over 5 and I add 2 pi, I need a common denominator, which would be 5. So times 5 is 10 pi over 5, which would give me 18 pi over 5. And if I take 8 pi over 5 and I subtract 2 pi, which we already figured out was 10 pi over 5, you get negative 2 pi over 5. So there's your positive coterminal and there's your negative coterminal. Alright, so how do you evaluate sine, cosine, and tangent when multiples of pi are added or subtracted to the reference angle? Well, you travel around unit circle to given measure, and then you can calculate your trig. Okay, it says, how do you find an angle on the unit circle that is less than 0 degrees or more than 360 degrees? You find a coterminal angle. Alright, so the next part is they're going to give you a point that the terminal side passes through. Okay? And when they do that, guys, this point would be x comma y. So let's say that they plotted it here. And there's my angle, yes? Well, you can picture a right triangle. If you dropped an altitude down, this height would be y. And if you dropped, and this length would be actually negative x. Okay, but it would be x units long. So we could do this to figure out the hypotenuse, and then once we figured out the hypotenuse, we can calculate the trig. And what's nice about it is, it's always, if you're in a circle, if you draw a circle around this, okay, your hypotenuse is always going to be the radius. So, if you notice, sine of theta would be opposite over hypotenuse, okay, which would be y over r. Cosine would be adjacent over hypotenuse, x over r. And tangent would be opposite over adjacent, which is y over x. And then to get your cosecant, secant, and cotangent, you would just reciprocal your sine, cosine, and tangent. Alright, so it says you're going to plot the given point on a graph like so. Draw the angle. Make sure your initial side is in standard position. Terminal side is from the origin to the point given. Drop an altitude from the point given to the x-axis. So if I drew a point over here, I would connect and drop an altitude. And there would be my right triangle. And then you can label the legs and calculate the hypotenuse and then find your trig. Alright, so it says, let theta be any angle in standard position whose terminal side contains the point -4, -6. -4, 1, 2, 3, 4, 1, 2, 3, 4, 5. -6 would be right there. So if I draw there's my theta. Okay? And what you do once you've got that terminal side drawn is you drop an altitude back to the x-axis, which will create your right triangle. Okay? Now, this distance is -4. This distance is -6. So if I do Pythagorean theorem to figure out the radius, okay, it's just that my radius, I drew the circle really big, but the radius of the circle would be like this, okay? So there's the radius of my circle. Ignore that outside one, I just drew it to show you what we're going to do. Alright, so to find the hypotenuse, I would have leg squared plus leg squared equals hypotenuse squared. That'd be 36 plus 16 equals hypotenuse squared. 36 plus 16 is 52. So the hypotenuse is the square root of 52. So here's my reference angle, theta. Alright, so if I want to do sine theta, keeping in mind if I'm going to use this instead of the picture, I mean you can use the picture, it would be opposite, which is -6, over hypotenuse, which is the square root of 52. Or you can just use this theorem, which says, in this case, x would be -4, y would be -6, and the radius would be the square root of 52. Using this information without the picture, sine is y, which is -6, over r, which is the square root of 52. Now I'd have to rationalize that. So that would be -6 square roots of 52 over 52. Cosine theta would be adjacent over hypotenuse, or x over r. The x-coordinate is -4, the radius is the square root of 52. Rationalize, and you get -4 square roots of 52 over 52. Tan theta would be opposite over adjacent, or y over x. My y-coordinate is -6, my x-coordinate is -4. Reduce that down, a negative divided by negative is a positive, divided by 2 would be 3/2. And then to get the other 3, you just flip these over. Cosecant of theta, if I go back to the original and flip it over, it'd be negative square root of 52 over 6. Cosecant, I'll just say cosecant, secant theta, go back to here and flip it, would be negative square root of 52 over 4. And cotangent theta would be 2/3. Okay? Alright, this one, they're going to give you square roots just to try and throw you off. If you plot this point, the positive square root of 5 is this way, it's 2 point something, and a negative square root of 6 is also 2 point something, so it's going to be about right there. Okay, so there's my terminal side, which means my circle does something like this, okay? If I drop my altitude down, or back to the x, alright, this is the square root of 5, this is a negative square root of 6, so to get my hypotenuse, leg squared plus the leg squared equals hypotenuse squared, which in this case is my radius. So if I square square root of 5, I get 5. If I square negative square root of 6, I get 6, equals r squared. That's 11. So my radius equals the square root of 11. So x is the square root of 5, y is the negative square root of 6, and r is the square root of 11. So sine of theta is y over x, so negative square root of 6 over radius, square root of 11. If I rationalize that and multiply the top and the bottom by the square root of 11, I get a negative square root of 66 over 11. Cosine theta is x over r. My x-coordinate was the square root of 5. My radius was the square root of 11. Again, rationalize, and I get the square root of 55 over 11. Tan theta is y over x, so a negative square root of 6 over square root of 5. Rationalize, and I get negative square root of 30 over 5. Cosecant theta, flip sine, would be the square root of 11, negative over the square root of 6. Rationalize. I get a negative square root of 66 over 6. Alright. No, so sorry. Cosecant would be the radius, which is the square root of 11, over y, which is a negative square root of 6, rationalize. Yeah, no, I'm good. Sorry. That would be a negative square root of 66 over 6. Yeah, we're good. Alright, secant theta would be the radius over x. My radius was the square root of 11. My x was the square root of 5, rationalize. And secant theta equals the square root of 55 over 5. And cotangent theta would be x over y, which is the square root of y over x. Negative square root of 6 over square root of 5, rationalize, I get cotangent of theta is a negative square root of 30 over 5. And there are my, oh, I'm so sorry. Reading would be good. All they wanted was the secant. Sorry, I did a lot of extra work, but it won't hurt you. Alright, so you do this one, hit pause, come back when you're ready. And hopefully you got 2/5. Alright, so if we plot this, -2, -5, about right there. So that would be my circle. Alright, if I drop an altitude, there's my right triangle. So I've got a -2, I've got a -5, and I need the hypotenuse. So the square root of -2, -2 squared plus -5 squared equals the radius squared. That's 4 plus 25 equals 29 equals the radius squared. So my radius is the square root of 29. So I have x is -2, y is -5, and the radius is the square root of 29. And cotangent is x over y, which is -2 over -5, which reduces down to 2/5. I didn't actually even need to find the radius because they were only asking me for cotangent, which doesn't have radius in it. Alright, you do this one, they want cosine. Hit pause, come back when you're ready. And hopefully you got 4/7. Alright, so here we would have this leg is 4. This leg is the negative square root of 33. We do need the hypotenuse for cosine, or the radius, so leg squared plus leg squared equals radius squared. That's going to be 16 plus 33 equals radius squared. And that's going to be 49 equals radius squared, so radius equals 7. So for cosine, I need x over radius. My x coordinate was 4 and my radius was 7. Yeah? Alright, again, the definition of the unit circle. The unit circle is a circle of radius 1, centered at the origin. If you're in the unit circle, okay, and before we weren't. If you're in the unit circle, the radius is 1. So our last formula is these were all over r's. And this was r on top, and this was r on top. But in the unit circle, your radius is 1. So this would be y over 1, which is just y. This would be x over 1, which is just x. This would be 1 over y and 1 over x. If you're in the unit circle, you have to be told you're in the unit circle for this to work. Alright, it says find the 6 trigonometric functions of 315 degrees. If I find 315 degrees, it's right there. So for 315 degrees, x is the square root of 2 over 2. Y is a negative square root of 2 over 2. And of course, in the unit circle, the radius is 1. So sine 315 is y. so it's going to be negative square root of 2 over 2. Cosine 315 degrees is x. The x-coordinate is square root of 2 over 2. Okay? Tangent 315 is y over x. So I'm going to have a negative square root of 2 over 2 divided by x, square root of 2 over 2. To simplify this, I'm going to keep the top, change to times, flip the bottom. The square root of 2's cancel, and I get negative 2 over 2, which is negative 1. Cosecant of theta of 315 would be 1 over the y-coordinate, which would be negative square root of 2 over 2. Again, keep, change, flip, and I get negative 2 over the square root of 2. Rationalize, and I get negative 2 square roots of 2 over 2, which that just cancels and gives me a negative square root of 2. Yeah? Cosecant, or secant of theta, out of room. Secant theta is 1 over x, so it would be 1 over the square root of 2 over 2. Keep, change, flip. I get 2 over the square root of 2, rationalize. I get 2 square roots of 2 over 2, which cancels, which just gives me the square root of 2. And then cotangent, cotangent of 315 would be x over y, so that'd be square root of 2 over 2 over a negative square root of 2 over 2. Keep, change, flip. The 2's cancel, the square roots of 2 cancel, and a negative divided by a negative is a positive 1. Right? Hold on, should be negative. X divided by y. Yeah, negative. Yeah, that one's positive times a negative is a negative. Yeah, I put 2 negatives. That's only 1 negative. Negative 1. Alright, so there's all the 6 for 315 degrees. Okay, find the following without a calculator. It says sine of negative 210 degrees. Again, I don't count so well backwards, so if I go to positive 210 degrees and reflect up, that puts me right here. So there's a negative 210 degrees, so I'm at this angle, 150, that has this x and y, and they want sine, which is y, so my answer is 1/2. Tangent of 5 pi over 3, if I go to 5 pi over 3, that's right here. There's my x and y that corresponds to that angle, and they want tangent, which is y, negative square root of 3 over 2, divided by x, which is 1/2. Keep, change, flip, and I get a negative square root of 3. Secant of negative 3 pi over 4. To get to negative 3 pi over 4, I'm going to go to positive 3 pi over 4 and reflect down. And that puts me right here at 225, or 5 pi over 4. They want secant, which is 1 over x, which is 1 over, the x-coordinate is a negative square root of 2 over 2. Keep, change, flip, and I get negative 2 over the square root of 2, but I have to rationalize, which gives me negative 2 square roots of 2 over 2, which gives me a negative square root of 2. Cosecant of 240, if I go to 240 degrees, that puts me right here with those coordinates. Cosecant is 1 over y, so that's going to be 1 over a negative square root of 3 over 2. Keep, change, flip, rationalize, I get negative 2 square roots of 3 over 3. Okay, so when you're in the unit circle, it's really simple because your radius is 1. Alright, in radians, negative 15 pi over 4. That isn't in the unit circle, but I might be able to travel there. 4 goes into 15 3 whole times. Take away 12, leaves 3 left over. So it's 3 whole pi plus 3 more pi over 4. So 1 pi, 2 pi, 3 pi. 3 pi plus another 3 pi over 4, which from the center is 1, 2, 3, 4, 5, 6 steps. So from here, if I go 1, 2, 3, 4, 5, 6, it's going to put me right here. So there's my reference angle. There's my coordinates. And tangent is y over x. So I have a negative square root of 2 over 2 divided by a positive square root of 2 over 2, which is going to be negative 1. Because if you keep, change, flip, everything cancels and I get negative 1. You don't get nothing when everything cancels. And in multiplication or division, you get 1. Alright? Cosine of 23 pi over 6. I got to figure out where that is. Well, 6 goes into 23 3 whole times. Take away 18, leaves 5. So that's going to be 3 whole pi's plus 5 more pi over 6. So if I do that one, I have 1 whole pi, 2 whole pi's, 3 whole pi's, plus another 5 pi over 6, which from 0 is 1, 2, 3, 4, 5, 6, 7 steps. So from here, 7 steps later, 1, 2, 3, 4, 5, 6, 7 puts me right here. Okay, so there's my 23 pi over 6, which has these x and y coordinates. And for cosine, it is the x coordinate, which is the square root of 3 over 2. Alright, sine of 11 pi over 3. 3 goes into 11, 3 whole times, take away 9, leaves 2, so that's 3 whole pi's plus 2 pi over 3. So again, I'm going to go 1 whole pi, 2 whole pi's, 3 whole pi's, and then I have to go another 2 pi over 3, which is 1, 2, 3, 4, 5 steps. So from here, 1, 2, 3, 4, 5 steps puts me right here. There's my angle, there's my coordinates, and sine is y, which is negative square roots of 3 over 2. And we're done. Alright, so calculate the exact value of 150, hit pause, come back when you're ready, and hopefully you got negative square root of 3 over 2. If you go to 150 degrees, that's right here. Okay, and they want cosine, which is x, and the x coordinate is negative square root of 3 over 2. Hit pause, come back when you're ready, and hopefully you got 4. Alright, negative 5 pi over 4. Well, if I go to positive 5 pi over 4 and reflect up, that puts me right here. So here's where I'm at. Those are my coordinates. Cosine is x. The x coordinate is the negative square root of 2 over 2. Alright, so given a point on the unit circle, how do you find the 6 trigonometric functions? Well, you plot the point. Draw a triangle. Draw a right triangle. Find missing leg or hypotenuse. Usually it's going to be the hypotenuse. And then you can calculate your trig. Alright, so we are at homework, which means we are done. So happy homeworking, and I will see you next time.